Welcome to Praveen Patil, College of Diploma Engineering and Technology. Myself Raj Givari, lecturer in Mechanical Department, and today we will discuss on the course Thermal Engineering for the third semester. So we will start with the first chapter, that is Fundamentals of Thermodynamics. Now, what exactly thermodynamics is all about? We will firstly try to understand what is thermodynamics. So there is a proper definition for thermodynamics, that is, it is a science for regulatory governing process of energy conservation. Now in simple words, thermodynamics is nothing but it deals with the interaction between energy and material. I repeat, it deals with the interaction between energy and material. Now in this thermodynamics there are various laws, 4 types of laws. First one is the first law. First law throws light on concept of internal energy. Zeroth law, which is the second one, that tells with thermal equilibrium and establish concept of temperature. Second law indicates the limits of converting heat into work and introduces the principle of increase of entropy. The third law defines absolute zero of entropy. Now we will understand this in detail. Okay, so we will see what is a pure substance. A pure substance is nothing but a state in which there is a change of the phase. Now here a pure substance is a homogeneous and invariable chemical composition, even though there is a change of the phase. Now for proper understanding, the example of a pure substance is a liquid water, mixture of liquid water and a steam. But the mixture of liquid air and a gaseous air is not considered as a pure substance. Pure substance is just in a separate form, that is a liquid water, mixture of liquid and water, all that. Over here in thermodynamics there are systems. There are 2 types of systems. First one is an open system. Open system is nothing but it is one in which matter flows into or out of the system. Most of the engineering systems are open systems. Now over here there are systems. This is the systems. Over here we can understand the concept of boundary. As you can see, this blue color border line indicates the boundary, and inside that blue color border line there we called it as a system. Now here in this example we can see that whenever in a cylinder a piston reciprocates, but the gas is present in a cylinder, that is surrounds as a systems, and this dotted line indicates, this one dotted line present over here in the system boundary, that is the real boundary. And when the gases exist, this we called it as an imaginary boundary line to that exist form of gas through the cylinder. Okay, so now we will be discussing about the second types of system, that is closed system. Now what exactly closed system is all about, we will be able to understand with these diagrams. Now here there are 2 systems, closed system and open system. Now usually in a closed system there is no flow of inlet and outlet. As you can see in the diagram, there is no flow of inlet and outlet. There is a boundary present in the cylinder itself, and the mass remain constant in this boundary. Whereas in an open system it is exactly opposite. There is a flow of inlet and outlet. The mass enters and moves out through a system. So this is the example of open system and a closed system. Now we will be discussing about the properties of substance. Now in the properties of substance there are 2 properties. First one is the intensive property and extensive property. Now what does this intensive property tells about? Intensive property does not depend on mass of the system. Intensive property does not depend on mass of the system. Now here you can see the systems and the mass. It does not depend on mass of the system. Example of intensive property is temperature and pressure, whereas extensive property is different. You can say it as the opposite. It depends on the mass of the system. Example, volume. Okay. Now intensive property, in an intensive property, divides by the mass associated with them to obtain the intensive properties. For example, if a volume of a system of a mass m is V, if a particular volume in a system, it is denoted as a V, then the specific volume will be represented as small v, not capital V. You can see the formula present over here. We will now discuss on flow and non-flow process. Now what is flow process and non-flow process? We will be getting an idea from this closed system and open system. Now in a flow process and non-flow process, the process occurs when the system undergo a change in state or an energy. Okay, there is a change in state in a flow, in a process. Now here what happens is, a process may be a non-flow. A process may be a non-flow when it is considered as a non-flow if there is a fixed mass with a definite boundary. If there is a fixed mass with a definite boundary, see here, if there is a fixed mass with a definite boundary which undergoes a change in states. Okay, so the example for this will be the substance which is being heated in a closed cylinder undergoes a non-flow process. So here in a closed cylinder, the substance which is being heated will go under which process? Non-flow process. Now here, whereas a closed system undergoes a non-flow process, the process may be a flow process. When it will be a flow process? The process will be a flow process when the mass is entered and leaving through the boundary. See here in the open system, when mass is entered and leaving the boundary, then it is being considered for the flow process. That means there is a continuous flow, inlet and exit, means it is being entering into the system and it is being leaving to the system. So this is all about flow process and non-flow processes. So we will check about the temperature. What exactly the temperature is all about? What is absolute temperature, which is being there in thermodynamics. So for a temperature is usually being measured with what? It is usually measured with thermometer, and those for the high temperature we use pyrometers. Now over here, if we find out that the gas will not occupy any volume at certain temperature, if a gas does not occupy any volume at certain temperature, then we say that has an absolute zero temperature. I repeat, then we say it has an absolute zero temperature. Now the formula for absolute zero temperature is given over here. Okay, so it is being taken in terms of reading of degree Celsius plus 273, and it is being denoted by K. K is nothing but kelvins. Now we will see about the specific volume. A specific volume is what? A specific volume of a system is the volume occupied by the unit of mass of the system. So here in a system, okay, the volume of a system is the volume occupied by the unit of mass of the system. Okay, in this, the volume occupied by the unit of mass. Now here we indicate specific volume in terms of small letter, that is small v, and its unit is measured in meter cube per kg. whereas the capital letter V will be used for the volume indication purpose. Okay, so this is of temperature and specific volume. Over here we will see the process, we will see here the cycle of operation. Now here this represents the diagram from 1 to 2, 2 to 3 and then 3 to 1. Here the directions are given from 1 to 2. According to the operation, according to the types of operation, there is a change of phase. That means from first phase to the second phase, there is a change of phase occurs. Now from 1 to 2 there will be a change in the phase, and then initially from 3 to 1 and it comes back to its original, that is towards the first phase. Now energy is being termed, embracing energy is transmission and stored energy. The stored energy may be in the form of mechanical and internal energy. Now based on this energy, there are flow process and non-flow process occurrings. Now what happens in a non-flow process for an energy? Now in a non-flow process there is no change of potential or kinetic energy. So if there is no change of potential or kinetic energy, hence mechanical energy will not be considered for the calculation purpose. Whereas for the flow process it is exactly opposite. Both kinetic and potential energy must be taken into consideration while considering the change of stored energy. Okay, so this is all about energy. We will see work and heat. Now what is work? Work done is nothing but when a force is applied to a particular object, that object will tend to move. So we can say it as a work done. Now here the force moves through a certain distance, right? Now in this figure there are two figures provided over here. This one is the first figure, this is the first one, and this is the second one. Now in the B figure, this part rotates and there is a fluid present over here, now which will result into the work done. Okay, now for the better understanding we will see the first figure, that is the A figure. I will just clear out this. Okay, so here what happens, whenever the pedal is pressed downward, as this is the boundary, as this is the boundary part, the fluid gives the pressure towards this boundary and towards the downward boundary. Also it is providing a pressure to the pedal, so the pedal moves upward, giving a positive work done. So this is all about the work done part. So in the second part of the video we will stop here. In the second part of the video we will discuss about the zeroth law, we will discuss about the first law, second law, and we will be looking for the Carnot theorem also. So we will stop over here and we will see you in the second part.